So that's because we couldn't finish the last day, but the idea is a kind of to have a full pipeline to say, okay, I developed this model and then I want to put in Kubernetes. And the straightforward way that I found in a kind of entry level for me as well, that's why I did it that way, because I'm not an expert, is doing serverless. Then you can containerize the model, but there are other tools for doing that. You can use Seldon or other that I find out during this week, prepare for this session, but I couldn't make on time, and I want to tell you something that is not proper, that I proper learned. So.
Okay, no worries, we can get going. So I think we start with the KServe part. Yeah. And then,
so one question, Nipinja, before to start. You are recording. Okay, no. Okay. No, you are recording. I want to ask you something before recording. So, what do you want to? We talk about something about the book. How is the platform in order that summarize what Kurin achieved to make the chapter 10? What do you want to?
Yeah. So you're planning to cover the KServe part right now, right? That is something which you are finishing up, right? And then post that, you are planning to and talking about then after that, how do you use you kind of want to get more into the part of the Seldon and KServe and other stuff, right? That's what you plan to cover, right?
Yeah, I was thinking to doing that, but we can discuss at that point. So, okay, no problem. I think we can go for the outline that I sent you, and then at the end we can have some spare time to discuss whatever topic or even address any question. No?
Sure. So yeah. So just a quick note that why we could not do it. We could not find the data set what we're looking for, which is given in the book. So we'll try to maybe spend some more time and see if we can get hold of it. So the idea is to kind of go back to the book and then try to look at the data set what is given in the book and try out their example what they mentioned. So, but we could not get the hold of the data set. So we'll try it one more time to get a hold of it. In between, there is still a lot of interesting things we can talk about, like KServe. So we'll try to cover that. And then let's see how much time we'll left with. We'll utilize the time for sure in that point of time as well. So,
yeah, perfect. So yes, I will do that. I will share my screen. So I will. So now you can see the. Okay, and now I can have more control. So basically, so hello everyone. We started to record it. So at the beginning was a kind of to agree what will be the content, because at the end we will talk about a little bit about the book. So basically what we are going to see today is to recap what we have done in the previous session, because the last session was expected to kind of to cover a full pipeline, that is develop a model using MLflow and then to serve that model using KServe. And the benefit of doing that is just because it's well documented, so you can try it yourself. And even I found very convenient because it's very entry level, so it's not a big deal. Unfortunately, there is an issue is that I explained before, is that when you develop something nowadays in MLflow, when you deploy serverless, that is something that I'm going to explain what is the difference between serverless deployment and container deployment. For whatever reason, is not working. So I couldn't have some workarounds on that. So basically what we are going to deploy is a serverless model that has been already defined. And we are going through that model, which is not the model that the data that we used the previous session. But I think it's very convenient that you can find how works a serverless deployment. So let's recap the previous session. So the previous session, basically what we did is just to develop a model. The model was the RDC, the likelihood that you can develop a coronary RDC. And that's pretty much what we did. We use Jupyter Notebook in order that, to work in a entry level, that you don't have to develop a full, we can say a full develop Python package or program. It's just using the benefit of Jupyter Notebook that you can add comments at the same time the logic of the program, you can develop a full model, train the model, and then tracking the evolution of the model. That is something that we have seen in previous session. So if we recap that, basically, is this notebook? The code is already shared, but I will put the link to the GitHub in order that you can take it. So at the end, basically, what we do, as long as we have the model already deployed, basically what we do is to test it out using MLflow, because with MLflow you can develop and track, but even you can run another instance and test it out how works the model. So after doing that, let's go for the next topic, which is the most convenient in order to introduce. Is now we have our model, whatever is the model, the data, and we want to deploy the model. So we have two scenarios to deploy a model. As far as I am aware, I don't know if there is another scenario. You can do it serverless and containerized. Containerized is something that we have already deployed. So we started with in a session that Nipintra took a model in Python and then packaged in a container, in a Docker container, and then queried the API that was included in that container in Flask. So containerize the model is the straightforward way in order that you can have the full control, because you can know what is inside of the model. You can ship code, or even you can ship code and the model indeed. And here we define the model, which is basically the binary pickle file, pickle file that contain all the logic, all the training that you can then test it out. So the containerized we have already done, and you can see the benefit. And the deployments that you can find is in cloud, almost AWS, Azure, all the things that I could explore and do some research. All of them, they have a version that you can ship the container. The goal of this session is not to go deeper in terms what are the services that every cloud has for doing that. It's something that could be explored in another moment, but just imagine that all the cloud, even at certain points, you can create your own infrastructure to doing that. But basically, all the cloud, they have a kind of a feature that help you to deploy your containerized model in the cloud. If you want to do on-premise, the solution that you can find is Seldon. It's not open source. It's a proprietary solution. And it's something that is used in the book. If you go for the book and read the full book, and in the deployment stage, you will find that he's basically using Seldon as a middleware or part of the framework to deploy the model. And he deployed the model using a combination of code plus the model. So basically what he's doing is to create a kind of abstraction of the Seldon framework to consume the model, and then this is packaged in a container, and after that create an open Kubernetes object inside of the Seldon framework to serve the model. So the containerized way is basically create a container and then use the framework that you're using, and the find that I found very convenient is Seldon. There are other ones that you can do some research and find, but Seldon is the one that is addressed in the book. And somehow it's very mature, because just because it's not open source, somehow they are very aware about to have latest version and the book issues. But let me warn you that it's not open source the product indeed, but you can run the community version, which is the one that is used in the book. So in a containerized way, you have the Seldon framework, which is well documented. But let's move on to the serverless. Once again, the serverless is basically to deploy a model, and here is the artifact of the models. And what is the artifact of the models? Are the binary file, which is the pickle file that we have already seen that we get in MLflow, and a definition of the model, which we saw in the previous session, that the definition of the model is a file that is ML deploy, when you have some information about the input of the model, the output of the model that is expected. in order that a serverless framework like KServe to take those artifacts and create a entry point, which will be an API at the end, that you can consume that model. One of the, one of the limitation of that is that you don't have full control because all the magic happen inside of the framework. And I experienced some issues doing that with recent model that I built, and it's very likely that when you have to go for that path, you have to be very careful, or you have to be very aware of the version of the different libraries that you're using. That's my gut feeling. So what I'm going to do is to deploy a serverless model using a model that is public, you can download, and we are going to explore when you download that model, what are the artifacts, and then how it's deployed. In order that if you want to run this by yourself and you want to go for the serverless approach, that how you have to package your model and then to deploy in an environment. Once again, in this path, you have the two solutions. You have the public cloud. They have different service to deploy serverless model. And if you want to run on service, on-premise, is the KServe. KServe is something that I'm going to introduce yourself. And KServe, you can find something that you can deploy in your own Kubernetes cluster or as an add-on in a full framework. That is something it will be covered later on. That is Qflow. Qflow is more like a platform, and one of the components that you can put in that platform is KServe. Just because if you want to deploy something serverless. So let's move on. So now I think we have clear the different path to deploy something. Is there any questions so far? Okay.
I think so. It's not a question per se, but just want to bring in the benefit of using serverless, right? For the model serving, right? And that has been used not just by KServe, of course. There is a lot of companies who are offering this kind of service to others as well, right? Because with serverless, as we know that we pay only the time we are using the resources, right? So if you try to set up a full-fledged setup for machine learning inferencing, right? It's going to cost you, right? But if you are only getting charged only when somebody runs your model or somebody takes a service, then you have to pay only for that particular time. So deploying with serverless is not something which is very common.
Yeah, and I didn't go further into analyze the different business case because I think this is a kind of uncharted territory, if we can say it that way. I mean, so it's not full documented in terms of use serverless for this business or use case and no serverless for this one. But somehow, as far as I'm aware, all the research that I have done, somehow the serverless approach is more for training, development, and even for some use case that maybe you don't need a kind of, I don't know, like open AI, a generative model that consume a lot of resource. So maybe the serverless could be convenient for something that, I don't know, maybe predict the next action or something that doesn't consume more resource. But as I said before, you need to do some research to have a clear picture when to go for one path or another. But for the development, I think is the most convenient one.
So did you say that KServe or the serverless is primarily used for the training purpose?
I haven't found that. The most scenario that I found is more for training, for developing, is that when you are doing, is just to reduce the time that you develop something, create the model, not a big model, a short model, and then you want to deploy and have an endpoint in your cluster, is the one that I found very easy, even for testing as well.
So KServe primarily for inferencing purpose, right? So there is two things, right? One is model training and one is referencing or inferencing a model, right? So
Yeah, inference,
KServe,
yeah.
so KServe would come at that point where you want to serve the model which is already been built. Yeah, maybe it is clear, but I just want to reiterate that. Yeah.
So let's go for have a look to the web page of the KServe, and we can explore together how it works. Basically, if you go to the web page of KServe, so basically you have all the hardware resource here, then you have your cluster Kubernetes, and on top of that you have Istio as a kind of layer to drive the traffic, but then you use Knative. I'm not an expert in Knative, but as far as you can see in the picture, is the common framework to deploy things on top of Kubernetes serverless. So on top of that is KServe. So basically what it's doing is that any of the model that you deploy in the stack, because it's something that we haven't mentioned before, but the stack that you use to build your model could be TensorFlow, because maybe you are using one of the machine learning library that is better in TensorFlow than learning the sorry, I don't remember the name of this one, which is the one that we use, or PyTorch. So what I mean with that is that KServe, basically, whatever is your code developed with the library that you're using, if you're using Python with one of these library, I'm not sure if you can use other language. I assume that it's very likely. So basically, when you create the artifact of the model that we will explore later on, KServe will be in charge to take those artifacts and create an entry point that you can start to consume that model. So basically, you don't have to create endpoint for the API, because KServe provide for you. You don't have to be aware which port you can deploy that. Somehow you can manage that in KServe, but basically you don't have to containerize your solution. It's basically you provide where are they stored their artifact. We will see an example of that. And KServe will take those artifacts, we download the artifact, and create the full entry point for that model for you. So it's serverless. You don't have to be aware of anything. For instance, you don't have to be aware of the security of the Python framework that you're using when you're developing something. Everything is inside there, because you are not delivering Python code. You are delivering the artifact of the model, which is the pickle file and the definition of the model, and even the libraries that it needed to consume that model. So it's very, very straightforward. And as you can see here, is a new concept that is the model inference platform. Basically, a model inference platform, as far I find out, is basically every platform that is in with the goal of the platform is to serve machine learning model. So it's something that you can Google, and you will find that model inference platform is just whatever you use. Qflow could be defined in that way, but basically is that, okay, I want this model, I want to have that model that is consumed as an API. So that basically what is going to do that platform. So let's see what is, and the word inference for me, it create a kind of confused, because basically inference is the result of something. But somehow you can understood in that way. It's an inference platform because you are getting the result of something that has been already previously trained. So that's the kind of rule of thumb that I have to understand what is about. So now that we have clear what is KServe, basically, if you want to deploy something serverless, you need to use what is called the inference service, which is the Kubernetes object that is basically defined to deploy the model. So let's have a look on that. So once again, the definition that you have here is belongs to Qflow, but is the best one and the shortest one that I found. It's basically the inference service is a custom Kubernetes custom resource that basically what it's doing is to deploy your server, your model, sorry, in KServe. So if we go for this document, that is the one that I'm going to use, you will see that here, this is what we have covered in the previous session, but they are using all the data and another Python. And as a result of that, they package the model, the artifact of the model in a Google Cloud bucket. And that's pretty much what they do. And this is what you have to deploy in Kubernetes. So it's very convenient because if you are training or developing a model, or you are trying to assess which model can be approached, you can create a simple pipeline if you want to start in a Jupyter Notebook, and then have some whatever mechanism that you want to do to create this Kubernetes object, which is basically consuming the package, which is a Bitbucket package in this case, what you put there. I didn't go further how many things that you can, how many storage URI you can use, but it's very likely that you can use NFS. At least in other platform you can use it. But at the end, it's basically an entry point when you put the data, the artifacts, and then you download. So let's go for basically how we are going to deploy.
Excuse me for that, Francisco.
Yeah, sure.
I missed it. So KServe is a CRD.
KServe is a CRD.
I deploy it like I deploy any other controller, and that lets me create.
Correct. It's a custom
deployments
resource
with the kind field for those services. Okay.
Yeah, it's the abstraction.
Okay.
So it basically remember that one of the previous session, what we do is to deploy the model using a container, and what we do for that is to create an image, then create the typical pod in Kubernetes that use that image. So at the end, you are adding more steps in that pipeline. Here, those steps is just you develop the model, create some artifacts, put the artifacts in a storage, and then KServe. Basically, what it's going to do is
KServe is my controller. Okay.
Yeah, it's a controller that is going to download those artifacts and create an entry point, an API for you that you can start to consume the model. If we compare with the exercise that we have to create a Docker image. In that Docker image, we have to create a kind of API as well to be consumed. And then you have to create a pod in Kubernetes and deploy the pod, and to be aware how the pod is alive or not alive. So there are a lot of steps on that.
Okay.
So that's in a nutshell. So if we go to the code that I will give you later on.
Just want to add one more point there. So can you go back to the same page on that that KServe page?
Yeah, sure. Let me switch to this one.
Yeah.
So
in the KServe, you could see that there are some built-in services or built-in frameworks. So you can see this TensorFlow, PyTorch. These are all your built-in frameworks what is available. So what does inbuilt means? It means that if you can just give a model. So if you can just open that link and you just, I think you had some other document also open, right?
I think I get your point, and I think I'm going to add something more visual. If we go, for instance, to this Python code, at the end, what I'm calling is to this library, to this one, sklearn, which is this one that you can find here, is this one. But for whatever reason, suppose that I want to do the same, use the same data set, but I found out that maybe the linear model or this one logistic regression model is better in TensorFlow, or is a straightforward in TensorFlow for whatever reason. Reduce the code of line that I need to use. So basically, when you use KServe, is that whatever is your logic in your Python to training the model, it doesn't matter. You give me I will show you how is defined the artifact. You give me from where you got the model, how you train the model, give me where are the artifacts, and I will prepare the full framework for you. If that makes sense?
Yeah, so basically the point is that you don't have to be just built in these frameworks. You can bring in your own framework also and do it. That is also a possibility. So just to quick note, what I did is I basically used the OLlama framework to add into the KServe, and I served the Llama to model through that.
Oh, so that's an example I can relate to. Yes, because I use Olama. Oh, so that's the way to put Olama into Kubernetes. Okay,
You
okay.
can try it. I haven't tried it, but it could be. It could be. So
No,
I
but
don't
Olama
know.
is something that's very, for me, is very simple and very well understood for me. Um, um, and okay, all right, noted, noted. I'm going to tinker around with that. Noted. Thank you.
So for me, the understood of this is that
Yeah, I have
when
a
you,
question here. Yeah.
yeah, sure.
What is the role of Knative like here? When I see the installation, it's not mentioned about the Knative layer. But in the diagram, they have mentioned about the Knative. So,
Yeah,
I just
Knative is just, yeah, it's because KServe is on top of Knative. So if you see the picture, Knative is a kind of a middle layer in order to provide all the framework for KServe. The interaction of that between of them, I didn't explore. But basically, you cannot deploy KServe. In a nutshell, basically, when you deploy KServe, you are deploying all together. You're
Yeah. So
deploying
the point is Knative is a serverless framework or Kubernetes.
correct.
Right. So basically, that is why we need Knative. See, the main thing is again saving on the cost wise, right? I don't want to run a model or I don't want to run a inference service if there's nobody who is consuming it. Correct.
okay.
So what happens
Yeah.
is when you are running any of these, when you're serving any of these models, you would run a pod. Correct.
Yeah.
And if there is no consumer of pod, what's the point? Correct. So
Yeah.
Knative is a tool which is a serverless, which can uh, scale down to zero if there is nobody using it, right? So if you have 10 of your customers and they have a random workload, right? So what you can do is you can basically serve all of the customers endpoint from a single Kubernetes cluster, right? And only when a request comes in, their model get invoked in a way, correct? So that's the idea that you create the pods as you need them through Knative, which has a feature of scaling it to zero to up to n, whatever number you would give. And of course, it would have other things like that auto scaling of the nodes and everything also in place.
Okay. Thank you. Thanks.
So the next step, if we go to this repository, the code that I will share. So if we are going to deploy a model with inference service, it's just because we have our cluster. So here you have all the steps to create your cluster. So I'm using kind here. And then to install KServe is just simple like this. Is you go to the well-documented user guide, and it's just to straightforward run this line. And as we have discussed previously, basically what it's doing to deploy this kind of bundle with Knative is transparent for you. So basically, the only thing that you need to be aware is that to run what has been mentioned before with Kind, you need to run the Google Cloud Kind load balancer in order that you can consume the model. That's pretty much what. Well, you can have external IP of your Kind cluster. So it's just basically what you need to be aware and to run before to run the installation. Otherwise, it will work, but you experience some issues, and at the end, it's better to have running. This is the Google. I know it's the compute kind load balancer. You need to have this cloud provider kind running first in order that it will act as a kind of external load balancer for your Kubernetes cluster, your kind Kubernetes cluster. And it's better to do it before to deploy KServe. Otherwise, you will have some issues. Is the straightforward way to fix it is delete the cluster and deploy again, having that already installed. So that's the main thing that you need to be aware before doing that. As long as you have this, I can share my. So you can have, for instance, I have here. Okay, I'm going to make this bigger, and this I'm going to make bigger. So kubectl, sorry. kubectl get node. So I have this cluster, which is the one that you have in the code, and kubectl get and istio, yeah, get pod. So after install KServe, you have the istio already installed as well. And if you do something like kubectl get ns, you have here KServe, which is the namespace where all the controller are. So if you get KServe get pod, you have the KServe controller there. And now you have a platform that you can run this object, this container object. But before doing that, let's do this step here. That is basically, sorry, it's this one. This custom resource, okay? And as you can see, basically the definition of the custom resource is to say, okay, I'm going to use this, which is the model developed in MLflow, and the artifact is already here. So what we're going to do is, if you have the Google tools, I'm going to go here. I'm going to create a new this one and cd temp. So, and I have this this new directory with what I have downloaded from this URI, and this is and if we go inside of the model, this is the way to provide a model for a KServe. So if we explore this in a visual, code, we can see that we have the conda file with all the Python dependencies for the framework. We have the definition of the model. Here we have the signature, which is something that we saw in the previous. We have this requirement as well, because you can serve the model using conda YAML file or requirements. And then you have the pickle file. It's that so simple. And the model that we are going to deploy is this one. That is well documented. Sorry, is this one. Is this one, which is basically how to predict the quality of the wine based on this data set. So, and the artifact that they provide is just the model. It's just the artifact of the model. Is the definition of the model, the requirements, and the conda YAML file, and the pickle file. They don't provide the code, so you don't have any information about that. It's well documented, because if you go to this user guide, if you want to start to adapt this code and use your model, you have a chance to see what is the logic inside of that. But this is very nice because they provide everything. They provide this entry point, which is basically the Google Cloud bucket, and that's all. So this is another way to share a model with other people that are involved in the field. Just provide the artifact. So let's move on and explore how is deployed this. So basically what I'm doing, I'm going to stop this. So basically what I have in my, okay, let's do this bigger, and I'm going to, so if I clean if I get pod, I'm in the default namespace. So after running this piece of code here, what I have in my space is this pod, well, with 2 containers inside. But if I run kubectl get inference service, and I have this, which is the custom resource that I already created here with the name that I created. That is MLflow version 2 wine classifier. So this is the custom resource, which if I go for get MLflow classifier, it's just the definition that I have already run here. So if I delete this, kubectl delete inference ML. So I will get the pod terminating. And for sure, I don't have the, if I try to get this, I don't have anymore. So let's deploy again, and we will see how it's. So if we try to monitor what's going on, we can see that it's creating a new, it's basically creating a new pod. Now it's going to run faster because somehow everything has been already cached. So it's going, but it takes some time. So maybe I should consume the model first rather because it take like 5 minutes or something like that. No, 5 minutes? No more than 5 minutes. So if you go for check it out what's going inside, it's downloaded the artifact and then start to prepare everything. So I think if
depending on how many nodes you have, so basically if you have multiple nodes, so
yeah, well,
different machines.
Yeah, it's a good point because we can do something like this wide, and I have it running in one of the nodes. So this pod is going to run in this pod. And to be honest, I didn't try to scale because somehow it should be easy to scale, because one of the benefits to go for a serverless approach is that you can scale, but I didn't find out how to do it. I don't know if there is a.
Okay, yeah, I'll kind of help you out. So if you just do this get pod, so that you do this inference service, right? The not this endpoint. You have earlier endpoint, right? Inference service.
Inference service, yeah.
So no,
it's not ready yet.
So you had it's not ready yet. Okay.
Okay, I think it's here in the definition of the you can add the number of the
no. It's not like that. So the whole point of the serverless is okay. So what will happen eventually is, but you are showing some output earlier, right? This endpoint, yeah. This is not this one. You are showing one more endpoint, right? Inference service endpoint, no?
Yeah, just only one is yeah.
So this is the pod only. So okay, can you just come out of it?
Sorry, say that again.
Come out of it. Cancel it.
Okay, cancel. Okay, sorry.
Yeah, and then just do inference service. Yeah. So can you just do that again? kubectl get inference service.
Yeah.
Inference service.
It's not ready. It's because the pod is still initializing.
So what will happen? Yeah. So what will happen is once that pod would become ready, in the second column you see URL there, right?
Mm-hmm.
That
Correct.
URL is going to be the endpoint where the model is getting served.
Correct.
So that would be your endpoint coming via Istio, right?
Correct.
Now what we have to do is we need to kind of go and access that endpoint. So assume that if that endpoint is serving like a curl request or whatever, right? So if you kind of go and access over a curl endpoint, so for every request you would see a new pod coming here. That is how it works.
You mean if it is a scale? No, it's
it will scale. For example, if you think about let's say you access a service, right? Think about there is a company who has developed a service. So if you go to their endpoint, and then if you just say that okay, you write a prompt, and then they'll give you some image out of it, correct? Now there are 10 customers who open that particular website, and each one of them write their own prompt.
Yeah.
So for every prompt, there is going to be a pod created in the backend.
Yes,
that is how it would work. That is how the serverless works.
Yeah. For instance, the business case that we can have here, if we have a kind of web page that is running or try to predict the quality of a wine based on some features of the wine,
right?
You can have the typical web service to provide that.
Yeah, that is what it is, right? So basically, it is depending on the number of requests you are mentioning. Correct. So that is how the pods are going to come, and that is what the scaling of that serverless would mean. So let's see if that has come. Did you get the endpoint? Not yet.
Yeah, I should. It's taking more time than.
Can you describe the pod and see what's happening?
Yeah, sure. So we can explore what is going. So if we could kubectl describe, pod ML. So it's basically pulling, yeah, is what is taking time is just is pulling an image for doing that.
Yeah, I just need to wait for that. Okay, we'll do that. So yeah, so what I did, I was go back to the example, right? So while deploying this Olama and Llama 2, right? So basically, if you know that Olama is a framework or kind of a tool to have multiple models. What I did is I built an Olama image with Llama 2 model in that, correct? And that is how I could kind of run it. Let's see if this works. Yeah, I think it's working now, right?
Sorry, I was doing two things and I cannot type at the same time. Sorry, what's the question? Can you repeat?
No, is it working now? Did you get the endpoint?
Let me check because I want to explore what is inside of the pod. So we have basically,
If the pod has come, then it'll also come up, right? Anyway.
yeah. So if you explore the logs, you can see that it's creating an endpoint to consume the API. So let's see how it's going. It has been already deployed. Okay, it's running. So now we can go for the next step. So my external IP for this cluster, if I go here and I go and Istio and get service. So this is my external IP for my cluster. Okay. So here I already summarized the step to consume. So basically, what you need to get the external IP of your cluster. So which is basically this one, to prepare a URL. So let's take out this and go for this one. And now I'm I think we are in the right place. So let's clean a little bit this one. So if I run this, sorry, once again, is the copy and paste in my computer is not working properly for whatever reason I haven't explored yet. So if I do something like this, wow, it's still failing there. So I'm here using copy. No. For whatever reason.
Open the terminal in the VS Code only, right? Would that work?
I don't know. I think it's, let's see if we use in this way rather than in the other. Let me check if this. Now, yes. So basically, what I'm doing here is just to ingress host is to get the external IP and the port is the 80. So here I have another snippet in order to consume. So this is the okay. Before to doing the next to execute the next part, let's do something that we have to previously that you pointed out that makes sense, which is get inference service model. So this is the URL of the model. That if you can manage that the entry point of the URL is the external IP of your cluster. So if you have a DNS and you can manage that this URL is the external, can be resolved to your external IP of the cluster. So you can go straight forward to doing that. Unfortunately, I don't have a DNS and I didn't prepare DNS for doing that. So what I'm doing is just basically to execute on the cool command upon to the external IP, but I need to provide this value here, which is the host I'm asking for in the header section in order to consume the model properly. And the input data is something that I have already here in the document, in the doc folder, which is the MLflow input, which is this JSON file, which is the definition of the model with the name of each column with some values. So if we run this this snippet code, we ended up having, we can consume the result of the model. So clear, and here we have the prediction, which is so let me clear this and do it in this way. So if I do this and then echo, I should have a no. Exactly. So here I have the execution of the cool command, and here I have the result of the of querying the model, which is basically the output. And it's something that is, I didn't go further to understand the model because the goal of this session is just how to deploy, not to interpret the data. It's supposed that is given the quality of the wine, which is 5, but according to the data set, the quality of the wine should be 1 or 0, not a number between 1, 0 or 10 or any integer. It's just 1 or 0. But for whatever reason, this model is the second version, and they decided to go not to 1, 0. It's give you a kind of score of the quality, and that's pretty much. So this is the goal of the session that we couldn't finish in the previous one. We have already consumed like 42 minutes somehow. So I think we have a spare time to address any question or to review anything.
Yeah.
So in a nutshell, it's basically we have deployed a model, and then we try to serve we developed a model and we deployed a model serverless in order that you can see the two part of a pipeline.
What we can do here, Francisco, is we can run that watch command. We can do a get pods and another terminal, and let's fire multiple records at the same time. If you go to that, open a different terminal, yeah, get pods you can do here, or another interface.
Yeah, but let me too, because I love to have transparent things, but it's not convenient for the video later on. So let me close this because it doesn't make sense, and let me open the terminal because it would take some time to take out the. So now we have a kind of background that makes sense for, and I can make this bigger. So what do you want me to do? So if I run kubectl get
pods, yeah, and keep in a watch mode, you can run it, watch mode, and then you can trigger one more request of that wine thing. You can just run the watch mode minus W, I believe, right? Watch.
Yeah. Okay, so let me. Okay, but let's do this. Let's do in this terminal in order that we can split the. So if I do kubectl get both
minus W.
What? So we can, and then we can split here in another.
Now you can make multiple requests of that request, right? A wine request, what you made.
If it's okay, I see your point. If we can kind of trigger that is going to deploy.
Yeah, run multiple of them.
So okay, let's try this. So we do this. Okay, yes, it's because I didn't have this variable first. But let's do something like no. Yes, let's do something like this. So delete this line and create the full snippet with this. I think you have to scale yourself. So if I manage to have this inside, it wouldn't scale. I think.
So to do that is so one is this endpoint.
I think if you edit this, so far I remember when you. That's the scale thing is something that I didn't explore. But I think to be honest, I didn't go to explore the API of this custom resource. But I remember that there is something like number of replica. At least in Seldon I can ensure that you can do that, because when you deploy in Seldon, one of the parameters that is mandatory is the number of replicas. And they give you, and you have to set up at least at once if you want to deploy something. If you want to deploy anything, you put 0. But in this one, I didn't manage, so I'm not sure. We need to Google.
Can you check if any HPA has been created by this custom resource?
Custom resource. Do you want me to do this? The kubectl.
Get HPA, yeah.
Just get HPA. PA. Yeah. Get kubectl get.
Oh,
HPA.
sorry. Yes, I didn't know that one. HPA. No, I don't remember. Would you have this as a kind of API resource? You should have here crap. You have this new resource. That's why you can consume as API.
So one more thing is that, see, this particular, all the requests we are sending from a single client, right? And from a single client, and our model is able to serve all of them. So that is one thing also, that it is not treating it as a separate request coming from different customers. That may be the case. I'm not sure about that.
Yeah, I don't know. It's well, we are addressing things that it was in the scope of the session, but I'm happy because there are some things that we can discuss in previous. So if but
Okay, I think that's okay for now. That's okay. I think let's not go too much on that. One quick thing is next
okay,
week.
okay. Now look, it's this one. We need to set up this.
Yeah,
So
that is
it's
correct.
like annotation. So
Yeah.
somehow we need to let's do it live. I think it would be good.
I need to leave. Francisco, is it possible for you to post a pointer to your GitHub repository?
Yeah, sure. Hold on, give me just one
I
second.
need to go.
It's on the Slack already. It's on the Slack already. If you look
It's
at the
in Slack, but I will give
yeah.
you I will give you here is in so where do I have the
Okay, quick note, next week I'm not available. So if any of you want to lead the entire session, it's fine, or else we'll take a break for the next week and do it week after that. So that is one thing, because there is a Kubernetes birthday event on the next Friday, and then Thursday I'll be at the venue. So I may not be able to join that. So yeah.
I already put the I put it check I put it in the chat so you may
Thank
have
you. Thank you.
so if I paste this
Yeah, it's there. It's already there.
so
Do not.
nothing is broken. Let's move on to but it's anyway here. Let's move this to let's see what happened. Now kubectl get pod. Ah, we have a new pod running.
Yeah. This is
So
the
the way to
minimum. Go ahead. Go ahead. Sorry.
so the way to scale that is just to add that in the notation section of the YAML file.
But this is the minimum. So the count, this is there. This is the minimum count which is need to be running. So it's you can make it to 0 also, I believe, which means if there's no request, it would be 0. So that
Yeah,
is
but
also.
yeah, but look what happened. Has terminated the one that we created and created two. So
Yeah, correct.
it's curious. So let's see if I run this. We have and they are both in the same node for whatever reason we don't know. But we need but it's a good exercise because at least we have answered the question that we have all in mind about
Yeah,
how
but
to
this.
scale the model.
Yeah, but this no, but this is the count is which is you are hard coding it. This means that at least these many instances would always be running. But make it to 0. Make it to 0. Let's do an experiment. Make it to 0. Yeah.
Yeah, I'm doing, so let's see what it's doing. So it's terminating. It looks like that the minimum one is always to provide you only one, at least minimum one, regardless that you put zero.
Let's just wait for some time. Yeah.
Because it's only one. So has killed the other, and but it's so here is okay. So I have there. So now that we have there, let's edit again and put here number 2 again, and let's see what it's doing with the both. Because now here you have like a kind of counter here, which is the number 3. But why is not running the new? No, it's only running one. Did I do it correctly? Yeah, I put 2. Who knows?
So we can look at what is this, what exactly this particular annotation means. We can understand the meaning of that. But anyway, the point is that these number of pods would increase as more number of requests would come in ideally. And what I'm guessing is because the request is being served from the same endpoint, from the same machine right now, it did not thought of scaling it, or it may be because of this seldom what you have, it's kind of able to serve the request.
Yeah.
But if you have another inference model, which would basically automatically scale as well. So I think, yeah, of course, we're not an expert on that, but at least we could reach at this point of time. So that is really encouraging. So thank you, Francisco, for leading the session and bringing it at this till this particular point. Um, so so next week it looks challenging for me, and you're also not sure, Francisco, right? Will be there.
I'm pretty confident I cannot make it. Next week, for sure, I cannot make it.
Okay. So, and anybody else want to lead the session next week, or we'll just take a week's break and come back after that?
I think we can have a break for a week.
Okay, fine then. So we'll take a break for a week, and then there is one chapter in the book which is not. I think we have not touched upon it, which is how to build a pipeline for the data pipeline. So the chapter 9, which is there. So the idea is that we should be able to build some kind of pipelines in which if we import the data, it should basically go through the process of cleaning it up, and some of these steps are there. So we have to check that. So Airflow and some of these things, we want to explore that. Let's see. Yusuf, do you want to try it out? The Spark part, Yusuf, are you there? Give it a shot. We can't hear you, Yusuf, if you are speaking. Okay, I think he's not, or okay. Yusuf, can you hear us? I put you on the spot, but yeah, that's okay. If you want to do it, let me know, because it's an independent topic, Yusuf. You can take it, and you can take the topic of Spark and Airflow. So these topics can be taken, and we can understand these topics independent of machine learning, like what we're doing, but it will set up the right context. So basically, if you know a quick demo about Airflow and then Spark, that is also sufficient. And then we can come and merge packet here. Yeah, so I think he'll come back to me. But anyway, next week we'll take a break. Week after that.
I think in the chat he's telling yes, I can. Need to deep dive a little more for a bit.
Great, Yusuf. So yeah, give it a shot. You can call me. You have my number, because yeah, we know each other. So yeah, just give me a call if you need some input on that, and give it a shot. I believe that would be helpful, and it can be an independent topic. So if you can think about discussing um, the Airflow and Spark independent of this particular flow. So one session can be only for Spark and Airflow, and you can just run simple demos, and then we can converge back to this particular example later point of time. Okay, you let me know. So you have 2 weeks time, and if you can do it, nothing like it. If not, then just let me know by next week. Yeah. Okay, so next week there's no session. I'll update the recurring invite so that people know that it's starting week after. So next week anyway, we don't have any session published. So that we'll meet, what today is date, right? 30th May, right? So then we'll be meeting next on 13th of June. Yeah, that is the current plan. And then after that, we'll try to look at this book, try to look at one final look, and then we'll move to Kubeflow and then finish it off. Yeah. Okay, sounds good, guys. Thank you again. Use Francisco for kind of your time, and then really, I think today we did a nice conclusion of what we have been looking at this particular model and MLflow, and then deploying it also. This is good. Okay, let's see you then in 2 weeks' time.
Thank you.
Thank you, guys.
Bye.
Bye.